Hi everybody. We can start the next episode, the seventh one already, of our series about Raymarching technology, which we use for modeling 3D scenes in 2D shaders. This time, we'll focus on a simple algorithm that allows us to repeat the display of an object infinitely without the need to write any complex code. So, let's get started. Before we begin, I'd like to mention that today is the beginning of July 2025, the holiday season, and even I take some time off occasionally. For this channel, it doesn't mean really much, except that I might not manage to release a new tutorial every Monday, as I've been doing for almost 2 years now. Nevertheless, I'll do my best to maintain that schedule. We'll see if I can pull it off. And now let's move on to today's topic. And once again, we'll be building on the shader we ended up with at the end of the previous part. I have it open in front of me. And if you've been following the entire series up to this point, your code should be in the same state. If not, there is of course the option to get all stages of this project from the Godot shader pack, which you can find on my Gumroad profile and which I've linked to in the description of this video. So, as I mentioned, we'll be dealing with repeating objects. Let's take this cylinder, for example, and take a look at its SDF function. So where is it? I think I have to scroll up there. Yeah, cylinder SDF. Very well, just to recap, the SDF stands for signed distance fields, and we use them to calculate the length of the ray, which we extend until it hits an object in our scene. In the case of a cylinder, we have this simple function, and for the position of the cylinder, we use the input parameter p, this one, which is a vector 3, meaning it's a point in space. You might already guess where I'm going with this. To easily replicate such a cylinder, we just need to apply some periodic function to the p vector. The most suitable option here is the modulo function, which returns the remainder after division. Let's start by replicating the x coordinate, like this. So I will just get rid of this commented out rotation part, and now p dot x is modulo of p dot x, and the argument is 2. Wait for it. Okay, as we can see, the cylinder is indeed replicated along the x-axis, but something is not quite right. It looks like it's been sliced in half, and from certain angles it shows ugly artifacts. And I guess that before we proceed, we should bring back the camera rotation so we can really see it from all angles. Let's scroll down to the fragment function, and here when origin is camera, I'll replace it with the original rotation code. Now it's better, and we can see the artifact. Can you see them? Okay, so that's what we need to address right now. Let's get back to the cylinder SDF function. And it seems that applying a simple modulo isn't enough. We also need to center the cylinder within the local coordinates of this transformation. So let's subtract half of the modulo argument, which is 2, so the half would be 1, like this, minus 1. Wait for it. Okay, that's much better, wouldn't you agree? We can now admire an infinite row of cylinders achieved with just one extra line of code. Now let's apply the same replication in the direction perpendicular to this row, so we will fill the entire plane. It would be for Z, the very same code, so let's just copy and paste and replace X by Z and X by Z. Wait for it. Alright, this looks really nice. And if we wanted to add a bit of variation in the third dimension, As well, we could try modifying the height of the cylinder at the current point, which would give us something like a wavy landscape. For example, like this. So I will just add here the modification of the h variable. And let's use, for example, sine of px plus pz and plus 1. So we don't have any negative values there. Wait for it. Okay, can you see it? It really looks a little bit wavy and gives us the impression of some very rough landscape. Of course, this is a very simplified example, and if we wanted to generate landscapes like in Minecraft, it would be better to use an actual voxel system, but that's a topic for another time. For now, let's make our code a bit more adjustable by getting rid of fixed values and replacing them with a uniform parameter like this. I'll name this parameter fold because we are essentially folding space into smaller sector. So let's go up to the uniform parameter section and write uniform float fold with a hint range. Initial value, let's say it's 2, like we already have it there, and the hint range would be from 1 to, for example, 50, and let's put the space step 2.01. Okay, let's get back to the cylinder SDF function. Where was it? Cylinder here. And I will also go ahead and comment out the line where we changed the height. So we are back to regular cylinders. Okay, and now this should be fold. This one should be fold 2. And here, instead of 1, fold divided by 2. And the same here. Fold divided by 22. Okay, and now we can change the parameter in the inspector and observe the result. Let's scroll down. Here it is. So let's make it like bigger. And I think it would be better observable if we just change the lookat point. So let's make it like this. All right. And or we can go down and now it's fully filled with cylinders and there are no spaces between them. So yeah, I guess it works as expected. Perfect. Okay, that should be enough for a basic understanding of object repetition using space folding. To wrap things up, I'd like to enhance our scene with something like scaffolding, which we'll generate using the same algorithm. However, since this object will be replicated in all 3 dimensions, we'll set the fold parameter to 20 so that we can actually see something. Okay, and we can remove the cylinder transformations. Now we are back to just a single cylinder. All right, and let's add a new SDF function, which I'll call struts SDF. To make the resulting object more customizable, I'll also add another uniform parameter. Okay, let's expand the code area a little bit, and I'll add it to the end of the uniform parameter section. Uniform float struts radius with a hint range and a hint range and the initial value, for example, 0.5. And this variable should go from 0.1 to, let's say, 4. And again, the step 0.01. Very well, let's write up the struts function. I mean struts SDF, and I'll put it before other SDF functions. So it should be somewhere here. Float struts SDF is the parameter vector 3p for the point. Nothing else is necessary. And now, again, we'll apply the space folding. So P is, or no, let's start without that, just to show how the structure looks when it's not replicated. So let's create vector 3L, which will be composed of lengths of the partial vectors. So that's why I call it like this. And vector 3 would be length of p dot x, y, and then the other components, so length yz and comma length xz. So this is just an auxiliary vector 3, and now we want to return the minimum value of this vector components. But before we do that, it's also necessary to use the strut radius, which will be subtracted from this. And now return minimum of Lx and the minimum of Ly, Lz. Very well. This is the definition of this strut structure. And let's place it into the scene. First, we'll define the material, for example, like this, so it uses the same texture as our sphere. So I think we should use this one, sphere 3. Let's copy and paste it to the end, call it struts. And now we need to change the SDF function. So instead of sphere SDF, it would be struts SDF. Okay. And there is no argument like this one because we don't use it. And let's just get rid of the translation of the shift. It uses only P, and we'll put it to the origin. And to display it, let's add this line before the final mix with the ground. So result is union of result and struts. Okay, it should be already there. Let's take a look. Yeah, here it is. Can you see it? It's just stretched indefinitely, and it goes in all 3 dimensions. Very well. So this is the basic thing, and now let's fold the space. So I'll go back to the here we are in the cylinder SDF. No, struts SDF function, and as I said, we should add space folding. So P is modulo of P, and again fold minus fold divided by 2. Wait. There we go. It seems that we are mostly seeing shadows because our look at point is too close to the ground. So let's try raising it a little bit more. Where was it? Look here. Yeah, now it's much better visible. We can tweak the parameters and observe the result. For example, what if we change the strut radius? Yeah, now it's much thicker. Now it's very thin. This looks pretty nice, I guess. All right, but it seems that the upper part is still too dark. So how about we bring back the second light source, which we are currently not using, and move it a bit higher. So I'll go down to the Raymarch function and reactivate the second light source. Where was it? Here, Raymarch, and we have the color of the getLight function with the first light source. Let's just copy and paste. So it would be this, but it would be increased. So we add both lights together, and this time we use light source 1, light color 1, and light energy 1. Okay. Is it better? Yes, I guess. It seems I already changed the color to white. It was red before, but it's definitely better with the white shade. And now we just want to put it higher. So the Y coordinate, and can you see how it's nicely illuminated now? Yeah, I think it's much better. And we can also just change the look at point back to something that we can observe the other modals in our scene, and shades and everything It seems to be just maybe too mixed up because we have two light sources, and the calculation might not be entirely correct, but I guess you get the picture. And we can also always comment out the second light source and work just with the first one. And now it looks, I guess, better than that. I think that should do for now, and I believe that with a bit of experimentation, we could build quite a complex scene this way, without the need to overcomplicate the existing code. Thank you so much for watching. I believe this approach could, for example, be used to enrich a 3D scene with background visual effects without the need to model similar structures directly in the 3D engine, which would otherwise put additional load on the CPU. I'll definitely try something like that sometime, and if the result is usable, I'll make another video about it. For now, take care, good luck with your projects, and I'll see you in the next video.